Okay, so our next example asks us to find the sine, cosine, and tangent of the acute angles of the triangle. My first question is, what angles are the acute angles of this triangle? Nolan? Okay, angles A and B. Obviously, C is the right angle, so that's not acute. The other two must be. So what we are going to do, if you paid attention to the last little lesson video, you saw that I always circled the angle that we are finding these ratios with respect to. Because depending on which angle you're finding these ratios of, your opposite and your adjacent sides are different. Hopefully you saw that. So let's start with angle A. So we are going to be finding the sine, cosine, and tangent of angle A. You need to make sure that you are denoting which angle this ratio is with respect to. So don't just say sine equals. It needs to be the sine of that angle A equals whatever the ratio is. Cosine of angle A equals, and then whatever the ratio is. Tangent of angle A equals, and then whatever that ratio is. Make sure that you have which angle these ratios are with respect to. So, with that being said, if I know that sine is opposite over hypotenuse, well, I have a little bit of trouble. From angle A, I don't know the opposite side. Oh, well, look at that. It's a 30, 60, 90. If the hypotenuse is 2, what would the length of the short side be? 1. And what would the length of the long side be? Radical 3. Good. Notice, previous knowledge is going to come into play, which is why we spent so many days on those special right triangles. The hypotenuse is double the length of the short side. Yep. All right, now that we have all 3 sides of the triangle, now we can find the ratio of the opposite over the hypotenuse. So this is 1 to 2. Cosine is adjacent over hypotenuse. From angle A, the adjacent side is what? Radical 3, the hypotenuse is still the 2, so this is radical 3 over 2. And then finally for tangent, this is opposite over adjacent. So again, from angle A, the opposite side is 1, the adjacent side is radical 3. So I'm taking 1 over radical 3. And then with our calculators, we will approximate these fractions all to 4 decimal places, unless it's an even decimal, like 1/2 is obviously not an approximation. That would be exactly equal to 0.5. So take your calculators out if you don't have it. You need to approximate radical 3 over 2. Emma, when you get that, tell me what it is. 4 places. Okay. Very good. 0.8660. Colton, do you have 1 over radical 3? Okay, when you get it, let me know what it is.
How do you do it?
Yeah, that's 15773 or 4.
Yep, 0.5774. You literally just take 1 divided by the square root of 3. Enter. Yeah, you might want to try that. Make sure you know how to enter things on your calculator. Otherwise, they do you no good. Okay, what I am going to have you do now is I'm going to have you guys find the sine, cosine, tangent ratios for angle B. Pay attention. Make sure that you are finding those opposite and adjacent sides with respect to angle B now. Okay, so take a minute, do that. Let me know if you have questions. Mark, what is your ratio for the sine of angle B? Give me the actual ratio first. Okay, radical 3 over 2, and then the decimal approximation was what? Good. So I was telling Maddie up here, I don't know if you heard me, the reason why I'm having you circle these angles, the reason why I keep saying with respect to the angle is because from angle B, the opposite side is now radical 3, the adjacent side is now 1. Maddie?
When I did radical 3 divided by 2, I got 1.2.
Okay, if you are not getting the correct decimal approximation, I would suggest you do radical 3, hit enter, then divide it by 2.
You have to do radical.
Because what you're probably doing is finding the square root of 3 halves instead of what you actually want to do.
You have to do radical 3 and then close the parenthesis. Put another
Yeah.
parenthesis.
Or close the parenthesis. All right, Justin, what is your ratio for cosine of B? 1 over 2, which is then 0.5. Jackson, what is your ratio for tangent of B? I'm sorry, what? Okay, well, from angle B, what's the opposite side? From angle B, what's the opposite side? No, what's the length of the opposite side from angle B? Okay, and then from angle B, what's the length of the adjacent side? 1. That decimal approximation should be 1.7321. Are there questions or comments on finding your 3 trig ratios? Before we answer that, we're going to take just a second to look at how we use our calculators to use those built-in. You may have seen sine, cosine, tangent buttons on your calculator before. Obviously, you've never used them, so let's take a look. Like I said, your calculators have the sine, cosine, tangent ratios built into them. First of all, this is really, really important. You need to make sure that your calculator is in degree mode. To figure out whether your calculator is in degree mode or not, we're going to do the first one together. If you don't get what you should, then it's probably not in degree mode. So, with that being said, on your calculator, you are going to hit the sign button. So if you need to take a minute to find out where that is, help people at your table. And then after you hit the sign button, you are going to type in 3, then 0.
Do we close the parenthesis?
It doesn't matter.
Okay.
Sine of 30 should be 0.5. So if you are not getting that sine of 30 degrees is 0.5, then you need to see me before you leave today so that I can change the mode on your calculator and show you how to change it. Is that clear? Okay. Because your calculators are all different. The way I have to change those modes are all different. I can't answer 30 different questions right this second. Okay? All right. Take just a minute. Those of you that are in the correct mode, find the cosine of 90 degrees and the tangent of 75 degrees. Cosine of 90 degrees is what, Trey? Yep. I mean, you should just be reading what you have on your paper at this point, right?
Yeah, but I feel like I got it wrong.
Well, tell me what you have.
I got 0.5.
No. Did you type in cosine of 90 degrees on your calculator?
Oh. That gives me 0.
Right, and it should. Okay. Guadalupe, what did you get for tangent of 75 degrees? 3.7321, very good. All right. Again, if you're not getting those on your calculator, check your mode. I'll get with you later to show you how to do that. Now to answer Steve's question of what do we even use these for? We can use trig ratios to find lengths of right triangles. What? So, in addition to, well, we're going to look at some word problems that will even further answer that question. But, so in addition to Pythagorean theorem, in addition to your special right triangle rules, trig is another way to find missing sides of right triangles. Okay? So what I want you to do, again, is keep in mind of those 3 trig ratios. You might want to write that acronym. Is this an acronym or is it a mnemonic device? Do you know the difference? I'm not sure I do.
No.
Anyway, I would write that at the top of your paper. So how can we use these trig ratios to find side lengths? A couple of things that I want you to notice first. The first thing that I want you to notice is that angle measure. All right, so what I want you to notice, first of all, is this acute angle is 27 degrees, which means it is not a special right triangle. Because what tends to happen is you guys look at these triangles and you assume that it's a special right triangle. 27 degrees is not one of our special right triangles, okay? So our special right triangle rules do not apply for this triangle. Just be sure you understand that. All right. Just like we've done, circle the angle that you're given. What I want you to think about is, with respect to that angle, what 2 sides are marked? With respect to this angle, what 2 sides are marked? Nolan?
Adjacent and opposite.
Okay, we have the adjacent side and the opposite side marked. What trig ratio does that lead us to? Look at your little tangent, exactly. Tangent is opposite and adjacent. So based on the side you're given, that leads you to which ratio you're going to use. In this case, tangent. So here's what we'll say. So here's what we are going to say. We are going to say tangent of 27 degrees is equal to the opposite side over the adjacent side. So that would be x over 10. Here's where your warm-up comes into play. I would make that tangent of 27 over 1. Now we have a proportion we can cross-multiply. Okay, so again, like your warm-up problems, I would suggest that you make this proportion. It's very simple then to cross-multiply and solve. When we cross-multiply and solve, we get that x equals, I would write this as 10 times the tangent of 27 degrees. 10 times the tangent of 27 degrees. And then from here, it's a matter of taking this and putting it in your calculator. So do it with me right now to make sure that you get the correct answer. 10 times the tangent of 27.
So you can't just do 10 times 27.
No. Tangent of 27 is not the same as 27. No, 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 no. No, 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 no. It is 10 times the tangent of 27. We should be getting, this is approximately 5.10. Make sure that you know how to use your calculator.
Wait, we don't round to the...
All right, let's do the next example together. I always start off by circling the angle measure that I'm given. I always think about, from that angle, what sides do I have marked? I have the adjacent side, and I have the hypotenuse. So adjacent and hypotenuse leads us to cosine. So cosine of the 39-degree angle is equal to
X over 7.
x over 7. Taylor, how did you get that?
Because it's adjacent over hypotenuse.
It's-
the adjacent is x, and hypotenuse is 7.
Good. Cosine is adjacent over hypotenuse. The adjacent side is x over the hypotenuse, which is 7. I would still put that cosine of 39 over 1 and cross multiply. And then from there, use your calculator. Steve, when you get it, let me know what you have. I'm sorry, what?
X equals
5.4, yes, good. I thought you said 0.4. X should be 5.4. Questions, comments before we move on to some word problems? Okay. You like this problem? A damsel in distress is being held in a tower. Her knight in shining armor is on the ground below with a ladder. So let's kind of draw this out. What? What's a damsel? Like Rapunzel is a damsel in distress. She's stuck up in the tower.
Except for entangled.
Kind of like that one girl in Shrek.
Yep. Fiona, yes.
I do not know her name.
All right. So we have our damsel in distress at the top of a tower. Her knight in shining armor is on the ground below. Let's say he's right here. And he has a ladder. So his ladder is going from the ground up to the top of the building.
Smart Knight.
Yeah, I know. Forget ropes. I'm just going to take a ladder. All right. When the knight stands 15 feet from the base of the tower, so from, let's say he's right at the bottom of the ladder. He's 15 feet from the base of the tower. And he's looking up at his dearly beloved. The angle of elevation to her window is 60 degrees. So from where he's standing on the ladder, the angle up to her is 60 degrees. How long does the ladder have to be? So we're finding the length of the ladder. If you want to just pull out this triangle, that might help a little bit. We have one 60-degree angle. We have a 15-foot side. We're looking for essentially the hypotenuse. We could do this actually a couple different ways. What's one way that we could do this? Mark? Yeah, it's a 30, 60, 90, so we can certainly use our 30, 60, 90 rules. We would know that the long side is 15 radical 3, but I'm concerned about what the length of the hypotenuse is, so that would be what?
30.
That would be 30.
So that's like...
That would be the length of the ladder. But let's also do it the other way using our trig ratios. So with respect to the 60-degree angle, we have the adjacent side and we have the hypotenuse. Adjacent and hypotenuse leads us to cosine. So cosine of 90, it's not 90, but 60, sorry. Cosine of 60 degrees equals 15 over x, using adjacent over hypotenuse. Adjacent is 15, the hypotenuse is x. I would make that cosine of 60 degrees over 1 and cross multiply. This one comes out to be a little bit different. We get x times the cosine of 60 equals 15, and then we need to do a little bit more work and divide both sides by cosine of 15. Cosine of 60. So we get that x equals 15 over the cosine of 60 degrees. Put that in your calculator. You should still be getting the same 30 feet.